We are going to have a group of presentations from the Visualization 3 class, ARC 7014, taught in the fall semester 2021. This is Ming Tang. I'm really glad to introduce a group of students. So I will just call their name really quick, so later we don't have to go through individual introduction. So we have people from Group A, Disha, Mia, Dima, Steve, Rishi, Connor, and Jacob, and Natalie, and Stephanie. The topics is ranged really wide range of topics related to digital computation, related to rendering, related to BIM. So the first group of presentation range from building information modeling, generative design, parametric design with Grasshopper, focus on the break, focus on the Voronoi pattern. We have presentations focused on the visualization using renderings, using the AI, using the virtual reality for architectural visualization. We also have presentation focused on the GIS, as well as integration of Rhino with Revit. So it's very, very exciting topics. Since we are recording this whole thing as a very short 5 minutes introduction, I do encourage you in the future, I will share the link to the full version on YouTube. I'm hoping this group of, the collection of the tutorials or the lecture demonstrations will become the repository for the future students. So when they pursue a very similar research topic, they can use your talk as a reference. That is the goal for recording and organizing this final presentation in my Visualization 3 class. All right, so let's get started from Disha. So Disha will be the first one. I guess the way we can present is each one just simply share your screen. Then after 5 minutes, we can switch to the next person, share the screen. This will be the easiest way. All right, so the first presentation from Disha on BIM. Are you ready?
Yeah.
Okay, so I will stop sharing and you go ahead.
Okay, so hi, I'm Disha, and my topic was impact of BIM on architecture with a main focus on generative design. Where do I share my screen from? Yeah, I got it.
Is the button right besides the microphone button on the top?
I got it.
Yep, we can see you.
Okay, yeah. So I started from the basic, like what is BIM, that is building information modeling, and how does it help architects and construction managers in their designing and structural analysis process. I then further went on to why is it used and its uses, like it is used in sustainable architecture, it is used for simulations, for document management, for construction management, specification, and in fact, even various services. Then I narrowed down my topic and went into the generative design aspect of BIM. Generative design basically means it tries to stimulate various output values for our inputs, like it will tell us how the furniture layout should be placed, what should be the minimum and maximum length for the views or for the views of the outside. It will also tell us about the minimum distance from the nearest exits and various other factors like that. So I wrote like what is generative design, just gave a brief idea about that, its advantages, and then I showcased using a large office space on how the desk should be arranged in order to maximize the outside views, and also how the maximum number of desks can be accommodated in that particular office space. So for that for that I used the software Revit, and there is tab over there called Create Spaces. I use that to get my study and observations. And as I went on my study, like first you open Revit, open your plan or build a plan and a model, and then you click on Manage tab, go to Create Spaces. Then you will see a pop-up coming up. Over here, you can see various type of simulations that can be done. I used the workspace layout, selected the areas and the furniture module that I wanted, and used the inputs that I needed to optimize my output. So when I click on generate, it will show various options and two graphs. The second one is the scatter plot graph, and the first one is the graph in which it shows various outputs. So from here we can see various outputs and which one is optimal for our design, and we can use that. We can also change the factors in scatterplot by using these options down here. So I used this option, and when we click on create Revit elements and then go to Revit, it will automatically pop up in Revit plan as well as in the model. So this is how I optimize the furniture layout and maximize the window views with the minimal proximity to the exits in my plan, in my design. So this can be used in various architectural purposes and can save cost and energy. So yeah, that was it. Thank you.
All right. Thank you very much. I guess we can hold the questions and discussions at the end, since I believe there's a few other topics is related to BIM and the generative. So thank you. And let's move on to the next person. And then at the end, I think everybody in group A, I want to have a group discussion based on the topics you presented.
Okay.
Yeah.
Thank you.
Very good. All right, so let's move on to second person.
All right. I'll share my screen.
Yep.
Okay, so I'm trying to share my PowerPoint. I don't know.
Here we go. Yep, I can see it.
I think it's lagging on my end. I don't see. Okay. All right, so is there a way to maximize the screen?
Actually, I see a full screen on my side.
Oh, perfect. Okay.
Yep.
So my research topic is about the generative design, and I explored the multi-objective optimization using Octopus plugin in Grasshopper. And in these slides, or in this research, I defined generative design. I looked into different research papers and master thesis, and different lectures, and looked into what generative design is. And I found that generative design is a process of exploring the design outputs, and it uses advanced algorithms, and it performs a genetic optimization of a model. So it evaluates and evolves each design solution over generations. It takes the parameters, the constraints, and the goal values that we're giving from the designer, and then in other words, the process of generative design, or the methodology, requires the artificial intelligence and the human creativity to generate permutations of solutions for complex problems. And here I talked about what are the benefits of generative design, and to be very quickly in here, it's easy, efficient, cost-effective, fast and reliable. It can give hundreds and thousands of solutions in a very short period of time, and can solve really complex problems with conflicting requirements that traditional ways are almost impossible and incapable of doing these problem solving abilities. And here I talked about 3 examples of how generative design is used today. It's used in many different fields, but these are just 3 specific examples: the Zaha Hadid Architects Center, and then the Autodesk office building in Toronto, and the acoustical ceiling in the University of Iowa's Voxman School of Music Concert Hall. And in these 3 examples, I talked about how they use generative design to design this building. So in this building, the curves are very well and specifically driven by computations, and then human analysis comes in place after doing the computations of the site, the sun analysis, and the views, the orientation, and so on. So it's a co-creative technology that involves the combination of the artificial intelligence and the human as well. And the form is carefully planned and generated using the algorithms of the generative design. And then in this Autodesk office that is designed by the Living, this office is a hallmark of a high-tech office because it has a very specific design that is user-oriented, and they took into consideration the welfare of each individual employee that works there. They took into consideration their preference for light, their preference for the way or atmosphere that they would prefer to work in. And they computed all of these and input all of these parameters into the system. And then from there, they generated the design solution. And they started with defining the design constraints, the objectives. Some variables were fixed and obvious, and some variables were required more planning. The fixed and obvious, for example, the number of employees was fixed, for example, and then the other required more planning, such as the conference room, space areas, and quantity of rooms. All of these were taken into consideration when determining the goals for this. So in this here, the last example that I want to talk about is the acoustical system in this university. And they also designed these panels in a very specific pattern that occupies different light fixtures and creates different, provides the space with different audio speakers and different reflections. It's very interesting, and all the penetrations in these panels were based on the generative design. And then the big question here is the generative design going to replace the creative process of a human being? The goal of the generative design methodology is not to replace, but to co-create. So the human defines the problem and he inputs the problem, and then the computer and the human works together to reach the optimal, ultimate, ideal solution. So in here, I just talked about the workflow of the generative design and how it can really work to generate industrial components, buildings, and cities. And then showed the generative design workflow in detail, how it starts and then how it evolves. And it's a recursive process, and it keeps repeating until it reaches the optimal solution. And then at the end, the human factor comes in place to manually refine and take the final decisions. And here I did a case study for a capstone project, the sustainable timber high-rise structure. And it's very interesting to me because it was doing the generative design using the Octopus plugin and using other plugins like Karamba and a Ladybug and Honeybee, and they had these this workflow, very specific workflow in order to reach their design goal. And these are the three main design goals: the sustainability, the structure, a maximum deflection, and then the spatial quality. And these were demonstrations of how they made Octopus optimize their solutions. I'm just going to run quickly because I think I am running out of time. In here, the Octopus, here I'm talking specifically about the Octopus engine. So it was developed by Robert Verlinger and the University of Applied Arts in Vienna, and it's a plugin that performs the evolutionary process in Grasshopper. And it takes the parameters that you input in your canvas in Grasshopper, and then from there it generates the solutions. And I'm talking about here the types of generative optimizations. We have the qualitative type, which is design-based, so it starts from scratch and designs your, for example, bridge or your structure, or the quantitative, where you have an existing design or an existing steel structure and you want to identify where the columns should go or how many columns you need in the structure. And here briefly talking about the difference between the Galapagos and the Octopus. Galapagos is an existing component in Grasshopper. It's not a plugin, and it's single objective, so it just optimizes one goal, versus Octopus optimizes two or more infinity amount of goals. And Octopus is more advanced, and it is a further development of Galapagos. Here I'm talking very specifically about how Octopus computes these solutions using the Pareto front in the plugin, and how it dominates these solutions. And then I'm here explaining the Octopus interface, and afterwards the brief tutorial about introductory for Octopus and how to start up with Octopus in Grasshopper. Also another idea that I want to discuss, and how I'm sure everyone's wondering how the computer is generating these solutions, how it can decide which solutions to leave over and which solutions to keep on, and what solutions can survive and what not. So in here I'm explaining this concept, experimenting it with Octopus as well. Here I'm explaining how to download it. Yeah, thank you.
All right, very good. Very good. I wonder how long is your full lecture or full presentation on YouTube?
It's 40 minutes.
40. Okay, it almost feels like you're giving a very condensed version of your research. Well done. Yeah, I look forward to watch the full presentation later.
Yeah, and sorry for going over time.
No problem. I think we have some time. All right. So let's move on to next person. Who is the next one? Dima or? Just check. I think Dima is the next one.
Yeah, this is what I thought.
Go ahead. Yeah.
So good morning, everyone.
Yeah, by the way, I think for the shorter version, you can treat this as a kind of like a teaser, right? Like a movie. You just show some exciting stuff, but you can rely on the full version to show the the step-by-step details.
Do you see my screen?
Yes. Yeah.
Okay. So today I am. I've tried to apply Grasshopper patterns to create wall bricks, and the scope of work is I'm trying to specifically apply the bricks in arches and walls that are actually existing. So it's not just a curve that like an infinity amount of bricks for the sake of parameter design. It is actually an actual surface that needs brick to be applied on it. And the way that I was doing it is I was trying to, so we started with our design project, and we have a brick and masonry museum for our design studio. And that was my struggle, how to draw my elevations the most optimized way, not having to draw my bricks one at a time. So I tried to find Grasshopper scripts online, tutorials, everything that has to do with it, and tried using each one of them, applying it on a part of my elevation and see how it will work. So the first problem that I have acquired and made me look into Grasshopper to begin with and 3D modeling for my bricks is that if you have this is a partial of my elevation, I have those arches here, and if you hatch it simply, you will find that the computer does not understand that the bricks actually need to reorient themselves around curves to be able to carry the compressive load. So this is a no-no. And that is what intrigued the process to begin with. So the first thing, the first solution that I found was how to create the brick, the brick arch. I tried to, and my problem I think was that I could not find. They're all the solutions are geared towards curves, and so I had to break my surface into a curve and apply my I had to create a box for my brick with all the dimensions. I have to specify the gaps between the bricks, and I had to I have the curve for the arch, and I divided the spacing between them, and the tangent is actually for the bricks to orient themselves with the curve, and this is how I got my my final model product. Another script that I found online, it was on Grasshopper, and this is, we tried using this basically. This one was used also towards curves, so it will just build for you an infinite wall, brick wall. The problem with it is that when you, so I transformed it a little bit. I created a surface, and it divides a surface into contours. It takes the lines that are resulting from from cutting the surface into lines and divides it by the width of the brick. And this gives you a number, and this was the problem. If this number, when it is, it does generate the rows into trees to create the brick rows, but the problem is when you have a fixed number with different length lines, you do not have a consistent gap between the bricks, and this is a problem. This is not how we build it. So this model did not work for me in this area of the elevation. It actually worked well for a curved wall down here, but not for this part of the elevation. So it's kind of like a puzzle piece where you collect different aspects from your scripts. This is another script that I found on a tutorial. It's called parametric house, and he had a nice tutorial for parametric walls. The model that he uses actually works well for penetrated wall if you want openings in your wall, but not if you want to actually build your wall. The problem here is still, again, that you have a number. When you, so I have the surface, I have the brick divided into lines. He uses a strategy that is called dispatch, and this dispatch actually gives you the two alternating rows of A and B, and then he creates also horizontal frames, and those horizontal frames, their job, they create the base for the brick to orient itself with the curve. The problem is that they need a count and not a distance, and this is my main struggle actually still until now. They need a count, so you have to know how many bricks you want. And once you have a fixed number, again, you will fall into this problem where you have, it's working down there where the distance is short, but then once the distance is longer, it fails. So if you have a straightforward rectangular wall, it works perfectly. Otherwise, you're gonna need to use something else. This is another script that I actually found on your website, and it was more for a wood or brick parametric wall, and the problem that I acquired was when I was going towards the height of the arch, is that there is no reference point for the bricks to start with. So they were starting at random or stopping at random places, which did not work on my elevation. And so, so this was the script that was used for it. I have my brick, the gaps, the curve that is cut, and then the contour lines, the plane. But again, the curve, it does have a distance, this is what I needed to actually have a reliable distance between the bricks. It just did not have a reference number for them to start from a certain place. So I ended up proposing, like, compiling all the knowledge that I have acquired and put together a script where I was actually able to fill the gaps, be consistent, and start at the point. But this is not a problem-free solution either. The script, so I do have the brick, I do have the gaps, I do have the surface, the lines, the dispatched lines into two curves. But the way I divided the curves here, I found this curved, dividing a curve with a point, and it has a reference point. And their first point, so I have group A and group B of curves, let's call it that. So the group A have the reference point all the way back to the brick itself. I deconstructed it and extracted surfaces and edges out of it. So one of the groups have their center start, or the reference point start with the center of the surface, and the other group starts, their reference starts at the center of the edge. And this way they are staggered when you look at them. And then I had to move the pattern B about half a brick on the x-axis so they can stagger. So I did that as well. I did that by multiplying the distance by half the width of the brick. And I have the geometry, I merged it, and I got it. And then at the end of the day, I decided that I wanted to actually trim the bricks to the outline of my surface. So I extruded my original surface. I actually extruded it and then made it into a box and split face for the bricks, which enabled me to actually clean up the shape, the bricks after I was done with them. So this is just screenshots of my surface being cut into rows, lines. This is a plan for my shape. Shows the problem with my solution is that I could not orient the bricks with the curve in a plan. They worked in an elevation, but they did not work on a plan. And the other problem that I have acquired is when I have my points, I divided my lines into points with a reference. The problem is it is insisting on adding a point at the very end of the line, even if the distance is not the distance that I have specified. So I think it's a programming thing, and I could not get around it. But I figured that I could just delete the extra bricks, and those are the domains, the planes, the horizontal planes for my bricks, and this is the final product. And this is what I have found, and thank you.
Thank you, Dima. I'm glad you shared all the iterations, all the struggles you have. Great. Yep, I look forward to watch your full presentation, and later we can have some discussions on the parametric design. Yep. All right, cool. Thank you. Let's move on to next person.
Let me just share my screen and we'll go ahead and get started. So I was looking into architectural visualization using Vray, because I've used Vray before, but I never felt I was being the most efficient and effective with it. And I think after exploring it, it's a very undervalued program that I think a lot more people could be using, even if you don't use it as a final rendering tool, but just as a tool to give you some different ideas about the quality of your space and your material. So what is Vray? Vray is a plugin software that is a rendering tool. And as you'll see on the Chaos Group website, which is the company that owns Vray, it's a plugin for a plethora of different programs: SketchUp, 3ds Max, Maya, Rhino, Revit, and others. So Vray is a very versatile tool, and it applies to a lot of different host platforms. So a lot of what I talk about in the tutorial that I run through will apply to pretty much any type of program that you're running it in, but I'm specifically using it in Rhino because I think, as for myself and for most people that are in this class, Rhino is the primary studio 3D modeling tool. So I think that utilizing the ray tracing that Vray has to accurately render light and material into your models, it allows you to analyze a lot of different aspects of your design that would be incredibly difficult or probably impossible to do otherwise, even if you manually draw these spaces. And so why should you use Vray? It provides you the ability to quickly analyze your work and make convincing arguments through your renders for design techniques and choices. And it provides you atmospheric quality that is accurate and organized, and you can render details within your work to make your presentation much more convincing and clear. So part of what I go through in my tutorial on this is that there are many different ways to use Vray, and there are a lot of really complex methods to get into it, but there are also some very basic principles that if you follow these basic principles, even when you start to get into the advanced options in Vray, you have a very good understanding of the basic elements of it, and you can really hit the ground running when you have to get into more complex configurations within Vray. And so I think a lot of people tend to not use it because it's seemingly very difficult and there's a large learning curve, but it is much less difficult than I think many people assume. And so in my tutorial and what I'm going to cover here, I talked about 4 basic aspects of Vray, and I think with these 4 basic understandings of Vray, you could arguably start to make final project quality renderings in about an hour. So it is a very efficient tool, and it's very powerful, and that's why I think if you understand how to organize your Rhino model, the appropriate settings for the environment tab in Vray, how to create and design and assign basic materials in Vray, and how to create lights and edit light sources in Vray, I think you have a very big advantage over people who perhaps don't understand how to use these types of rendering tools and get a better understanding of your space and materiality and atmospheric qualities. And so what you'll see here is just the comparison of what your typical Rhino model view looks like versus the actual rendering that you can get out of that model. And this took me maybe 20 minutes to assign all of this material. And so it's quick, it's easy, and this image on the right presents a much more compelling and convincing argument and image than this model form on the left. So that was a really quick and short lowdown on what I covered in the tutorial, but the overall tutorial that we're turning in is about 23 minutes. And so I would highly recommend, if you have any interest in it, Chaos Group offers a free trial for about 30 days, and you can utilize it in any of your old models and see how you feel about it. But I think it's a great, powerful tool, and I would highly recommend it to anyone, even if you don't use it for final quality renders, but you just use it as a tool to analyze your project as it develops. And so with that, I will close and just end my presentation. Thank you.
Thank you, Steve. Yeah, I'm sure this video tutorial will be a good asset for all students. I think the Vray rendering with the physically accurate lighting and material is very essential for architecture visualization. Yeah, look forward to watch that full tutorial later.
Thank you.
All right, let's move on to next presentation. Okay, Rishi. I cannot hear you. Is your mic on?
Can you hear me right now?
Yes. Yes.
Yeah. Okay. I had some preferences that I had to. I'll try sharing my screen. Give me a second. My share just like keeps loading for some reason. I don't know why.
When you share, do you have options like share screen or share PowerPoint? Do you have that options?
It's just share content, but it's just like loading.
Looping.
Mm-hmm.
Okay. Try to share. Stop sharing and sharing again, just your screen, not the content.
Share content.
Is that in a PowerPoint?
Mm-hmm.
Okay. Is the PowerPoint in the SharePoint in the class folder?
No, I downloaded it on my computer.
Okay, I see. We can come back to you if you want to do some testing. Yeah. Okay. So some minor technical issue, I guess. I guess we can move on to next person, and then later we can back to Rishi.
Okay.
All right, Connor, you want to go?
You should be able to see it now. So my presentation is on VR and architecture, sort of touching on various topics like one, why would you even use VR in the first place? And then moving into the accessibility of VR, how VR is currently being used, looking at overall pros and cons of using VR. And then I decided to take a look at some recent innovations, both in VR, the VR space, and in adjacent spaces. And then at the end, I kind of wrapped it all together and said, okay, well, you're interested. Here's some of your options. So moving into it, so why use VR? There's a lot of different business and marketing aspects with it, and creation of presentation documents and cost-effective alternatives to like showrooms, booths, in office, using it for live renderings with real-time updating, visualizing spaces in a 3D and 360 manner, pre-construction troubleshooting, and again, the creation of promotional work. Looking into how accessible it is, this is really touching on like right now what's available. Recent innovations as well have brought the cost down a lot. But beyond that, there's still program fees depending on what programs you want to use. There's time, training, associates, and then sometimes there's even other costs if like you don't have a computer that is quite set up to handle VR in the first place. Then we're shifting into how it's currently being used. Again, touching on the business and marketing side versus your in-office sort of design CD side. In place of showrooms, providing AR technologies during on-site construction, and then you can do some simulations of real-world scenarios, even tapping into using game engines and VR social gathering spaces to sort of do some tests. And then in office, again, real-time renderings, designing at one-to-one scale for massing visual, and it's even useful for attracting employees to sort of kind of have a notch in the idea of working on new technologies, working with emerging technologies to kind of stay ahead of the game. Pros and cons overall, we're looking at cheap startup costs, competitive advantages, integration between disciplines, maybe not necessarily VR directly, but VR related programs offer this integration, real-time rendering and adjustments. Some of the cons being there's a fairly steep learning curve depending on how deep into it you're going. Sometimes even require dedicated personnel, especially if you're utilizing game engines. It's not as active and non-personal, and in a non-person environment, with COVID, a lot of firms have gone to a hybrid work from home setup versus working in the office. So using VR is a little bit more difficult. You can do it from like a person's home, being able to set up and show something, but in terms of using a real-time rendering plus adaptation, it's kind of difficult to do that. And then also there's a constant upkeep. It's still technically an emerging technology. There's constant updates. There's a lot of new stuff that's constantly coming out, especially as innovations keep coming out. And then talking about innovations, we'll start with the VR specific technologies. First off, the new programs training in VR for real world scenarios is safe, cheap, and it's becoming way more accurate. There's a lot of cases of, surgery, people training to do surgery, actually practicing in VR versus say like on a cadaver or whatever, construction, and even sometimes in, I'm blanking on the third one that I had. And then touching on it, prices have decreased. I'd say 5 years ago, I think one of the cheapest headsets was probably like $700, $800, and now you can get tethered one for as cheap as $300, and untethered ones for also around that same price range. The top of the line is only $1,000, where I'd say a couple years ago it was probably like $1,200, $1,300. And then Unity and Unreal with the creation of universal file formats. I think this is one of the things I was sort of found that I thought was really, really interesting. There's sort of in process / the creation of, in addition to ones that have already been created, universal file formats that allow for easy transfers between programs. I know we touched on it earlier in class with the DataSmith file, but there are also in process in the creation of other file formats that could be used across even more programs. So touching on the broad related innovations, so there's just an overall increase of creation of programs. This is mostly just due to the accessibility of VR becoming just going through the roof, because more people can get it, more people can use it, more people can learn to use it and innovate on it, and just sort of improve the technology as a whole. I touched on the creation of universal data formats already, but there's also even been an increase in program interconnectivity. Rhino Inside for Revit 2022, being able to design, parametrically design something in Rhino using Grasshopper, importing that into Revit to use in a very specific program that is really good for creating the floor plans, creating the materials, and adding it onto it. If that even becomes better used, the creation and design processes are just going to become it's just going to improve. Also, there's been an increase in no-code development programs, and I assume most people are like, what? Think Grasshopper. These are programming without the actual need for coding. They use graphical user interfaces to configure different commands. Grasshopper is a no-code development program inside Rhino, and they're coming out with more and more of these. I think one of the article I was kind of basing this off of and looking at it was talking about Squarespace, which is a website development tool, and adding on to being able to take these and add on to it, making it more accessible, making these other programs more accessible, adds on to the exponential increase in innovation of these programs and related programs that are just, adding it all together. It's just going to make everything really, really good. And so, tie it all together. all right, I sold you. What are you looking at if you want to get into it? I offered sort of your low end, your cheap free option versus your sort of high end paid option. So starting on the low end, you have an Oculus Quest 2. It's a standalone headset, but on the caveat, because of the way it functions, you will probably have to use a game engine to install a program on it to be able to use it. It is very, because it's inside out and it's not tethered to a computer, it requires these programs to be able to function to its full capacity. But on the other end, you have something like the Valve Index, which is a tethered headset. You can pretty much use it with whatever program, and it's really high end, and it looks crisp. It's really good for your real-time renderings. In terms of programs, looking at Unreal and Unity, which are your game engines, great accessibility, free resources. I've started to learn Unity myself, so there's a lot of options in materiality and modeling. Also, it's free. And then on the other side of it, you have some of these paid programs like Inkscape and Autodesk Stingray. They're fully integrated into existing workflows, meaning using Inkscape specifically, and there's a demo that I've actually, of using it. I did the free trial. It was pretty much you install Inkscape, you load up Rhino, and it's literally just like a plugin. I just click start, and then I can put on my headset and then just walk around. In the demo, I used one of their sample projects just to make it easy for presentation purposes. But yeah, and there's a link to that also, since you may not necessarily be able to click on it in the video. It'll be in the description of the YouTube video as well. So these are links to all my different sources as well. So you can find it in the PowerPoint.
Right. Thank you, Connor.
Yep.
I think definitely VR is a very, very exciting technology. I'm actually considered to offer a class in the future, teach how to do Oculus Quest development using the architectural workflow.
Mm-hmm. So, I'll keep my eye out then.
Yeah, good topic.
Yep.
All right, thank you. I guess we are just move forward to next person. Then later, Rishi, you're gonna present at the end. All right, Jacob, go ahead.
Okay, can you see my screen?
Yes.
Okay. So I chose to research Voronoi diagrams, discovered in the 1600s, and it's kind of a diagram studying efficiency, looking at a generating point in the center, and every single point within each cell is closer to that generating point than any other point outside of the cell. And they're kind of made of three basic elements. The generating point in the middle, you have these edges between the cells, and then you also have the vertices where edges meet. Uses for Voronoi diagrams are pretty expansive outside of mathematics. You see them used in aviation, biology, astrophysics, robotics, computer graphics, and those are just to name a few. They're also used for studying viruses, which could be, kind of applicable to COVID and everything, what's happening now. So it'll be interesting to see how that plays out. But they're kind of used to study how things like viruses move and mutate over time. These diagrams are also seen expansively throughout nature. You see it in the wings of insects, you see it on giraffes, you see it on turtle shells. You also sort of see it in dry dirt, which you can see here, which is quite interesting. Honeycombs, bubbles are also examples. And then you also asked me when we were pitching our ideas to you of looking at actual projects, and I wanted to find a project that didn't use this type of diagram or pattern just as a facade, but one that was kind of more ingrained into the actual idea of the project. So I found this house in Greece, and they were using the Voronoi diagram to actually inform the spaces beneath them. So it was kind of a more meaningful use of the pattern, the diagram, versus just having this pattern applied to the building. So in theory, like for this project, the cells become the rooms below. It's also seen evidently that the cells inform the vegetation above. So it kind of creates this rational geometry in this wild place, but somehow effectively connects these two realms together. And then these are just kind of showing how they came up with this project, using those generating points, those seeds, and then creating the cells, and then kind of narrowing down the cells to form the rooms, and also have a priority of views. And then I simply tried to like take those ideas of the diagram, and which is in my video, but I walked through like how to create, how to unroll the surface. You can pretty much use this script for any kind of surface, but I chose to do a rather simple one, but starting with like unrolling it, then creating the seeds and the cells of the Voronoi, and then later on extruding that form into a mass, and then eventually using like the surface morph command, you'll like take that extrusion and effectively like drape it over the original surface that you had, to create a pretty unique form. But so I won't go into all the details beyond that process, but it's kind of detailed further in the video. So yeah, that's it.
Thank you, Jacob. I'm glad you did the recording of the whole process. Also, the case study, using the Voronoi almost create like a parcel, right? Land layout. That is quite interesting. Yeah.
Which I included with the bibliography, the source for that, which it would be kind of interesting for people to look into that project because it's pretty unique. So.
Yeah, it seems like a quite different system than the the planning are using in the history, the grid-based parcel, but this could be more biological like land layout. All right, thank you. Let's move on to next presentation. All right. Let me see.
Hi, I think I'm next.
Yep.
Okay, so. Can you guys see my screen? I think it might be frozen.
It seems like a dark screen.
Yeah, let me. I think my computer just froze on me.
Okay.
Let me try to shut it down real quick and get back on.
Yeah, I can come back to you. Do you want to present later?
Sure. Yeah, let me try to get this back up, then I can present next or later. That's great.
Okay, so I will let you present after Rishi.
Okay, thank you.
He has similar share screen issues. All right. Talk to you later. Let's move on to Stephanie, if you are ready. Yep, I can see your screen now.
Okay. For my tutorial, I was looking at Rhino inside Revit. This Rhino inside Revit is a plugin that you can use to merge the three programs of Rhino, Revit, and Grasshopper. So the first step that I showed was that you first need to download the plugin, and the plugin was really easy to download. It was a quick Google search, and the plugin's free. And then once you download it, and then I think you just need to restart the program, it appears, and I realized my images were a little bit not that clear. So it appears in this tab in between add-ins and modify. And once you go in it, you can just hit this button to the far left, and that starts to launch Rhino and even Grasshopper into the Revit program. And then to get into Rhino, you want to open Rhino through Revit instead of just opening Rhino in a separate program. This will create a pathway from the work that you're building in Rhino, and it will start to appear in Revit. And then any applied uses through Grasshopper will start to you'll be able to see the image once you apply Grasshopper in Revit. So for the tutorial I did, I took the bunny that we've seen a lot throughout the class, and just to simplify it, I've reduced the bunny mesh just because I was not sure how complex of a form I could get into Rhino. But after playing around with it, I don't think I really needed to reduce the mesh because the Rhino was able to pick up on a lot of the more like complicated angles and forms. But essentially, I opened up Revit, I opened up Rhino through Revit, and I opened up just a file I already had, and you could create a new file directly off of it. But for this, I just opened up the file I already created. And then in the green, you'll see that I have this form, and it'll come into play later on in the tutorial I had, but that was for connection points that I'll create. But to get the bunny into Revit, I needed to create a Grasshopper script that would turn the bunny into some kind of architecturally focused element. And for that, I thought that I wanted to make the bunny structural. So I wanted to make the bunny lines into W-shaped beams. So that's what I did for the tutorial. But essentially, like, I have two meshes. The mesh down here for step 5, that's the mesh I used to hook into the bunny. And then this mesh up here is what I used to hook into the green connector shape. This is just zooming in on the bunny mesh. So for the bunny mesh, I wanted the edges of the mesh, so I took the interior edges, and from that I needed to create a curve. From the tutorials I was seeing, the best way to get a beam created was to get your form into a curve. So that's what I needed to do on this step. And then it mapped this curve into the Revit item I selected right over here. I don't know if you can see my mouse.
Yes.
So to select the Revit item, it's set up how, if you're familiar with Revit, that a lot of the families are first built out of categories. So, if you scroll through this, and you'll see it in the tutorial, I scroll down in this search box, and find structural framing. That's what I wanted to make the bunny out of. And then in this drop down button right here with the W shapes, in my Revit model, I only had these W12 by 26s in the model. And you could, if you had more options, different structural framing options would pop up in this dialog box, and you'd be able to select your desired family. But the W12 by 26 worked in this application, so I just went with that. And then I also had one more Revit specific element, and that was this selecting where the level would start. In my Revit model, I only had 2 levels created, so I imagined that the bunny would sit at level 1 and not at level 2, so that's why I have level 1 created. So anything from level 1 and above will be applied in this Grasshopper script. So I connected the level to this beam, this where the beam is being created, and then the categories are connected through that. And then I'm taking the curve that I had, and that's being connected. So all of these are coming together to create my beam. One part I didn't mention is down here, and that's the points. So when I created the Revit, or when I created the beams and looked at it in Revit, and I have this shown in my video, they didn't join very nicely, and it was a little bit distracting how like 3 different beams would try to connect to one point, and it didn't look quite nice. So that is where that green mesh geometric shape came in, and the shape formed at all the points of where the beams are touching, and was able to create a nice connector piece and kind of hide the gaps that was being created. And everything that I'm creating in this Grasshopper script needs to be applied to some type of Revit element. And Revit doesn't really have a connection piece family, so I thought a generic model would be appropriate for this application. And that's the ending element I put in, and then just I baked the 2. So you'll see that in the Rhino dialog, it's starting to create these beams, and it's creating the connector piece. I baked them and assigned these pieces to different levels, and then just cleaned it up. And then this is what is showing in Rhino. But then simultaneously, whatever's going on in this Rhino program does pop up in the Revit program. So I could have split my screen and show them working simultaneously. But this is the baked items appearing in Revit. The red is carrying over that shaded and wireframe kind of toggles that you'll have in Rhino. So to get rid of it, I just simply went to the off button and turned them off. But now that we're in Revit, you can see that these beams, these are the W12 by 26 beams. They're all created individually. They're all pinned, so if you wanted to move them and manipulate them, you have to unpin them. But they're all successfully in the Revit model, and also that generic item, the connector pieces, are successfully in there as well. But yeah, I thought that was the end of my exploration, but I thought it was really useful to be able to create something that you would not be able to produce this in Revit without the plugin, or you would not be able to produce it easily. So I thought I was successful trying to find the differences between the 3 programs and figure out how to use them together.
Very good. All right. Yeah, I'm really glad you found a way to make the generic model connected from Rhino to Revit. That's good. Look forward to read the full tutorial.
Thanks.
All right. Let's move on to next person. Let's see who is after Stephanie. Natalie, have you presented GIS related?
Let me see if I can load back in.
Okay.
Okay.
Do you want to try share screen?
Yeah. Can you guys see my screen now?
Mm-hmm.
Okay.
Yep.
Okay, so for this project, I wanted to look at GIS software and also like taking that a step further and how it can be integrated into a Grasshopper script and how it can kind of make your life easier and help out your architecture. I started using GIS this semester, and you can see on the right, these are some maps I've generated since. And what I found is that knowing how to use like a GIS software is really useful in the beginning stages of your design because it helps analyze the site better and like the urban context of like the people movement. And so I was interested to see how that could be taken further into like maybe your actual design, or if it could be studied in a different way. And so I just want to start off with talking about what GIS is. It's a geographic information system. There are computer and software tools for gathering and analyzing data connected to geographic locations and their relations to human or natural activity on Earth. GIS analyzes use data to provide visual clues that help people discover deeper insight that they couldn't without a traditional spreadsheet. I think that's like the main takeaway, that it's like a very powerful analytic software, and it helps people understand like the spatial patterns and relationships. So the importance of GIS is when dealing with big issues like climate change, population dynamics, and natural disasters. GIS can survey the whole land, and all these elements relate to architecture and affect the building and the design that you are then going to do. So some GIS systems include natural Earth data, NASA Earth observation, OpenStreetMaps, is which I'm going to be showing today. But there are like very many different systems and different shapefiles that you're able to download. So where Grasshopper comes in, I know we've gone over Grasshopper a lot, but it's a modeling plugin for Rhino that uses visual programming language and allows you to reference Rhino geometries from and create geometries to bake or Grasshopper geometries to go back into Rhino. So then when I was in Grasshopper, I was looking at different plugins to use, and I found Urbano, and it's a Grasshopper plugin and allows you to load urban data from GIS into Rhino. This enables you to build contextual models that can be used for simple visualizations and site analysis to complex mobility simulations using the loaded street grids. So in my demonstration that I recorded, I want to show how you could use this Grasshopper plugin, Urbano, with the GIS software in OpenStreetMaps, and how you can easily create a 3D massing model of any region in the US or probably the world that has OpenStreetMaps. So to get started in the demo, you want to go to Food for Rhino first and just download Urbano. And then once you do have that open and it's in your Grasshopper, you want to go to OpenStreetMaps.com. It's a really simple, like user-friendly website, and so you can hit manually select different area, and you can search any part. I picked Lower Manhattan for this, so you can see like different height elevations. And then these 4 points are used when you go into Grasshopper. In Urbano, you want to pick the downloaded, the OpenStreetMaps generator, and then you put your points in. You can export this file, so it's already saved, and then when you run it, that's your file that you have forever. If you need to change the points, you need to start it over again, so it's cached, so it's always there for you, which is nice. So then you can add the URL and that path, so then you can go on, which I did, to create a deeper script that you're able to create the massing of New York, or Lower Manhattan is what I did. So kind of talking about it real quick, like the different steps, and then in the tutorial, kind of like I go step through step how to do it. But what you wanted to do is once this file is created, you want to add the different components. So it's the building, the amenity, and the street information. And then once this is added and you add your path file to it, you're able to add the polylines to get your roads in, and then also your building footprints. And then from there, you're able to add the amenity information into the building, so you're able to get specific information about where restaurants would be, where clubs would be, where bars would be, all in this one file. And then once you do that, you're able to combine it into one file, and then you're able to make a massing model. And so then this is the end result, is that it gives you a really detailed out massing model, and like even you could see like kind of the point down here and stuff, like it goes in and it's very kind of in depth for just being like a quick script. Like once you know what you're doing, it doesn't take long to do. So you're able to bake the massing out, and then you're also able to bake the roads out and like the different contour information. And so that is what I focused in mostly on for this. But also with this software, you're able to use a lot of like mobility. So you could see the distance it kind of takes to move around on a bike versus walking versus a car. So kind of in that initial architecture, like design phase, it's good to analyze the site more. So this is just another like baked out view of like what it looked like when it was done. Okay, so that's all I have for today. Thank you.
Very cool. I think GIS connection to Grasshopper is awesome. I'm glad to see it's actually able to capture the building roof details, not just like a box, right? That's really nice.
Yeah, I was surprised by that too.
All right, wonderful. I guess we have. Is Rishi? You are the only one left.
Yeah, I think
Right.
I'm the only one.
All right. Do you want to try to share the PDF one more time? If not, I will just go ahead and share my PDF. I download from you.
I've been trying every time since everyone's presenting, but it's still like.
All right. So let me do that. You just let me know when you're ready to move on to the next page. Okay. Yeah. Go ahead.
So hi, I am Rishi. I'm presenting how the meta would affect the design world, and most importantly, the architectural world. So I'm trying to introduce what meta is and how it changed itself from Facebook, and how it's trying to, and what methodologies it's using to get us or get people into a 3D and interactive platform. So these few lines were directly picked up from the website. They say that the metaverse is the next evolution for social connection, that the company vision is to bring the metaverse to life. So they're changing the name to reflect the commitment to this future. Moving on. So this is what they advertise it as like. So it's going to be some 3D spaces in the metaverse, which will let people learn, collaborate, social, pretty much everything you'll be doing, what you do now you will be doing in the metaverse or in a virtual world. So all this came to importance in life because of this COVID situation, and it just became a trigger. Meta was in development for a very long period, but Zoom meetings and WebEx made it more possible for people to accept it. So the way Meta is building the metaverse is through three different methodologies or technologies that they have been investing into. Those are like virtual reality, augmented reality, and smart glasses. I'll be just briefly telling you what all three and how they have been like trying into. Everybody knows what virtual reality is. So these are like 3D stimulated environments. But all the environments you would see are like virtual. They try to simulate as many senses as possible. They're trying to use touch, smell, and vision to produce these artificial worlds. Meta believes that they are the gatekeepers for this artificial world. Moving on to the next. So the way Meta is promoting virtual reality or the idea of 3D visual platforms where people would interact is through collaborating with this brand called Oculus. So for you to immerse yourself into a reality which is all coded, you need to have devices like Quest 2, which is the brand that they're promoting and collaborating to make this possible. Moving on. So in the full-length tutorial, I've tried to like put videos like briefing about what virtual reality and how Mark Zuckerberg has like released and what he means by virtual reality and how work in virtual reality happen, how Zoom meetings can be more virtual and interactive rather than just being a two-dimensional pictures on a screen. So it's like a 3-minute video.
Yep.
Moving on. The next comes augmented reality. Augmented reality is like a bit advanced version where it's trying to amalgamate the real world with the technological advances of 3D modeling that we see today. So I'll be dwelling deep into what augmented reality is and how it can affect architects and designers in this present world. So Meta has collaborated its field or like side of augmented reality with a software development company known as Spark AR. Moving on, Spark AR has released how augmented reality has been started to become one of the platforms where people can know better. For example, you're moving in a museum and having all kinds of exhibits. Augmented reality can interact with the museum to inform you about what the exhibit is, which was prior done by guides or like audios where they need to have to be in sync. But in these cases, you just like put your phone forward, they give out information. I've like tried to use a software and demonstrate like a small tutorial about how you can use augmented reality today in the present life for you to present your buildings and like make it interactive with the present world. Moving ahead. The third part is like smart glasses. So smart glasses is a combination of augmented reality, but like having a supercomputer as small glasses. So they're trying to use glasses which would like for now record videos, but this is the same way that they would start putting augmented reality in every instance of your life, where every move and every interaction you'll be doing with the real life would be guided with software encoded plugins that would like pop up for you to like understand what's happening. So Meta has collaborated, moving to the next slide, Meta has collaborated with Ray-Ban, which is called the Ray-Ban Stories. They have released some clippings and videos how these function. And moving ahead, there's some Mark tries to collaborate and explains how the advancements of smart glasses and augmented reality with real world is going to happen. Moving ahead. So the whole point of this research was to understand how it matters for architects and designers in this present world. Through the last of the early 2021, the idea of digital assets and digital economy has raised abruptly. So people have started investing into digital items and digital markets. The digital items that are already more than like a $10 billion market in this present world. But what's important is to understand how these assets can be marketed and have value. So that is something which is introduced in the new blockchain technology is NFT, which means non-fungible tokens. That means that every model or every asset.
Oh, excuse me, I cannot hear you. Rishi, it seems like I lost your audio. All right, am I the only person who cannot hear him?
I was disconnected. I'm back.
Oh,
Yeah.
okay, good. All right, I can hear
Yeah.
you.
So the idea of how to like generate economy is by introducing NFT, which is like a non-fungible tokens, which means that every model or every asset that you create in this present world is, in the technological world or inside Meta would have a token which is like called the NFT. So it's unique. No one can like replace it or destroy it. Them being like technological tokens, they can be like updated, but the previous model would lose its value. So every model or every code would have something called NFT attached to it. For example, I've just put a small video about like an artist, Krista Kim, who had sold her first NFT-backed digital home. So she made a digital like a home, which is called Mars Project, and she sold that virtual house for about like $500,000, which is about like more than any North American city, homes in any North American city. Moving on to the next. So there's the new investment is virtual real estate. So people started buying places or like real estate inside the virtual world, like in metaverse. So Metaverse is an open software. It's not controlled by one person. So it's like a contribution of people creating verses and like developing a better and a bigger verse. So companies like Decentraland and Sandbox have already created places inside the metaverse, and they're contributing to the open chain. Recently, Decentraland has sold about more than like 900,000 real estate inside its platform where people would buy and invest. So this is the best place where designers have leverage to like exhibit their skills, like spreading from the physical world as an extension to the virtual world. All their works and all their buildings that they want to produce can be a part of the metaverse. Moving to the next. So what is an architect's role in this? Like metaverse needs massive contents of entertainment and everything that we have in the present world inside the verse. So that we need to create like experiences which have like amusement parks, movie theaters, casinos, virtual schools, because everything that's possible in the physical world is possible in the metaverse, and people would be dwelling into it more than the present world in the near future. So for these to create, we need architects that need to develop code and makes it possible by 3D developing softwares. And every architect can create a unique NFT, design-backed NFT, where they can generate revenue out of it. But the whole part of here is the idea of luxury about what you create, because there's nothing which stops you from something like codes or any rules that the city has, but it just immerses you into pure creative buildings. So there have already been assets like holding digital assets, which have already come with like lots of furniture buildings where people indulge themselves, like meeting rooms and everything have been created by designers and already launched into the metaverse. So there's a huge opportunity for architects to become a part of the metaverse and in a way become a part of the ever booming IT, like information technology sector in this America or any other world. Moving on to the next. So how do architects be the bridge between physical and the virtual world? The idea of digital twin that we have discussed in the class comes into action here. So so digital twin is a practice in the AEC industry where people like architects like us would use it to bridge the gap. So according to Autodesk, a digital twin in construction engineering and architecture is a dynamic, up-to-date replica of physical assets or a set of assets. So whether you build a campus or a city or rail with a bridge, that brings together design, construction, and real-time operation data. So digital twin simulates, predicts, and informs the decisions. So it basically tries to um, get the real data using the eye of like digital twin to accommodate, like bridge it into the virtual worlds. So that is how we would be like architects and designers would be asset for Meta to all of this to happen. Moving to the next slide. So I've tried to like put some softwares and like advancements that have been done in the field where people have already used, like designers and architects have already used um, augmented reality or virtual reality to put themselves into the metaverse. So this is Ref Anil. He's a designer who uses like machine language to code buildings. So in this video that I've like put in the, it's in the main like the elaborated tutorial about how he uses machine language to decode and put forth the Guggenheim as a building. Moving to the next slide. So as she was talking about ArcGIS, this is something I encountered. Like ArcGIS has already advanced itself into the field of virtual reality. So they put this software with having like 5 easy steps or 5 steps to create existing cityscape or an imaginary cityscape that you want to see in the metaverse or in the virtual reality. So they just like you need to choose your satellite image or any area that you want to develop, choose the terrain, add the buildings that you have modeled in any 3D software, add details, and just export them to, and they'll be compatible with your 3D VR headset or like any platform that you're using for the VR experience. So basically, you can create your cityscapes and you can start indulging yourself into it. And these can be, as I was speaking of an NFT, you can attach these with like NFTs and sell them and resell them in the metaverse platform. Moving on. So I'd like try to like put to like a simple tutorial of the software Adobe Aero. So Adobe Aero it's still in the beta version because it's still very new, and this basically lets you understand how easy augmented reality and how can we like designers and like architects use augmented reality to put forth and like explain and make it more interactive with the physical world. This tutorial like explain. So one is a desktop app, and once you finish or like understand how it's done, you transfer into your iPad or mobile to see it and like amalgamate in the real world. The next slides try to like put screenshots. So once you open Adobe Aero is a free software because it's still in the beta version. You just need to sign in and like download it from the Adobe suite. Once you open it, you have like a create new button. It opens like any 3D software, opens a small screen with XYZ like a plane, and you press import. So you can import like OBJ, STL, any kind of format that we use for importing in our 3D softwares. So you get the model inside. So I just try to get a volumetric model of my studio project into it for an example. Once you get that in, you can scale it or you can like place it. In the tutorial, I've tried to make example of like to show how we can I put a robot here and try to see how the robot travels through the path to show how the public would travel through it. So this is, once you get it and export it as .real file, you can get it into your phone, and it's pretty simple. It scans your surroundings and you can place your model. You can see the robot. You can add functions and actions to this robot to show how he's going to travel through the space for you to explain or present it at a platform where you want to explain it to like a jury panel or anything or a client or something. There are like many actions that you can generate or like add to these, like spin, bounce, zoom, scale, any kinds of things, and it just becomes so easy for you to interact with the real world and the model that you have placed here. That's it. Thank you.
All right. Thank you, Rishi.
Mhm.
I look forward to see our full presentation.